it's like listen to like when I was solving the actual problems, I was like, okay, maybe it's like the NXN and the NY thing. Like it's that's
yeah. No, you got it. Yeah, that's it.
Hello, Dr. Chan. Are you able to hear me?
Yep, I can hear you, Ivan.
Thank you, sir.
Mhm. All right, it's 7 o'clock. Let's go ahead and get started. All right, good evening, everyone. How's everyone doing today? We're breaking new records for the amount of people coming in person nowadays, but you know, it is late. Okay, all right, so today we have an activity. It is going to be
Dr. Chan, someone asked a question in chat.
Oh, okay, thank you. Oh, good. Yes, thank you. Yeah, I'm doing good. Thank you so much. All right, so this activity is we're going to be implementing or we're going to be practicing basically everything we talked about for the last couple of weeks about shell and beam elements, right? And so you want to look at the geometry. We are going to be working on this bridge geometry here, okay? And so what we're going to be doing in this activity is because this bridge is comprised of a lot of very thin and slender geometries, we're going to transform it into shells and beams. And so we'll learn how to do that in ANSYS, and then we'll simulate it from there, okay? So I'm not going to sugarcoat it. This activity is probably the most involved in terms of things that we're going to do together. And there's a lot of places where people kind of tend to get lost. And so, you know, there is a possibility that, you know, you might not reach a point after the lecture today where, you know, you can kind of finish it off from there. So, you know, definitely, you know, this is definitely a good day to, you know, go back and watch the recording if you ever kind of get lost, because I do want to move, you know, at a decent pace today just to make sure that most people can kind of get to a stable point. And so if you kind of fall behind a little bit just because you're having issues with the software, you know, I'll try my best to try to catch everyone up as we go along. But definitely, you know, the recording is going to be there so that you can kind of look and see the steps along the way. Okay, all right. And so because this activity is a bit more involved, and I know because you guys are also working on the midterm project as well, I extended the deadline for this activity. And so you're going to have 2 weeks to do it. And so it's going to be due on Wednesday, March 22nd, which is 2 weeks from today. And because I don't want it to overlap with the next activity, I'm having it due basically right before the lecture. So it's not going to be due at the usual 11:59 p.m. timeframe, but it's going to be due at 6:59, which is right before the lecture. Okay. Okay. All right. And so I think that's it for my announcements. Are there any questions I can answer before we get started for today? Okay. All right, so first thing, just like we usually do, let's go ahead and download the CAD file. And so if you go to our Canvas site here, you can download this bridges.iges. Okay, so that's the CAD file we're going to be working with. And just like always, we're going to start in Workbench, right, where we're going to start this this activity. Okay. All right, so the first step here, and so this is problem 1 on the activity, is to convert this geometry into shells and beams. Okay, so we're going to spend the majority of our time here, and so because it is a bit involved, but you remember the whole purpose, the whole reason why we're converting this geometry to shells and beams is because if we try to mesh this geometry, with other element types, and so we try to mesh it with hexahedrons or tetrahedrons, you know, it wouldn't work as well because all of these geometries are pretty thin and pretty slender. Okay, and so if you try to mesh this with you know, with solid element types, at the very least you would get situations where you would only have one element in the thickness, and in the worst case it might even fail to mesh because of, you know, how thin some of these geometries are. Okay. All right, so let's go ahead and get started. So just like we usually do, let's start with static structural. So I'm going to take static structural and drag it up here. Okay. And then I'm going to import the geometry as usual. So I'm going to right click on geometry here. We're going to import the geometry. And then we're going to import this bridges.iges geometry. All right, we're not going to do anything with the material properties this time, and so we're going to leave them as a default. So let's just go ahead and start working on the geometry, okay? And so the first thing we're going to do is you're going to right click on geometry, and then you're going to click on edit geometry in SpaceClaim. Okay? So this is a new program, so we haven't used SpaceClaim up until this point yet. So we've only just been using Design Modeler. So SpaceClaim is I think SpaceClaim is the newer CAD program that ANSYS is trying to try to kind of push forward. And so its tools for making shells and beams are a little bit more robust than in Design Modeler. Okay? All right, so let me go ahead and click on Edit Geometry in SpaceClaim, and then we will get started from there. No, I would not like to participate. All right, so just like every program in ANSYS is going to take, maybe like 30 seconds or so to start up, but then once you start it up, you should have the following, okay? So is anyone having trouble opening up the geometry in SpaceClaim?
Professor, why do we need to open the geometry?
So because we're going to be modifying it, and so
Okay.
we're not going to be working with this geometry exactly. We need to modify it to basically transform it into shells and beams. So,
Okay.
So yeah, it's different. So I know most of the time we don't really work with the geometry, but today we are going to be doing just so we can transform it. Okay. All right, so just a quick primer on the mouse controls here because it's going to be useful. And so to rotate the geometry, I like to click down on the center button. And so if you have a mouse, just click down on the center button and you can rotate the geometry. Okay. If you want to pan, and so if you want to just kind of drag the camera left and right, the way I usually do is I hold Control on my keyboard, and then I click on the middle mouse button, and I move it left and right, and then that pans the geometry left and right as well. Okay. So again, just the middle mouse button by itself, rotate, and then middle mouse button plus Control will pan. Okay. So the reason I'm kind of mentioning this is that we're going to be making pretty significant changes to this geometry, and so being able to kind of view it from all angles, rotate it where you need to, is going to be very, very useful. Okay. All right. So I picked this geometry on purpose, or in reality, if you want to know the story, I went on GrabCAD and I picked one, but it actually worked out pretty well because it kind of illustrates a lot of issues, or we're going to run into a lot of issues that usually occur when you're trying to transform a geometry like this into shells and beams. Okay. All right. And so, with that said, this geometry right here is not the cleanest geometry in the world. So there's going to be a lot of issues that we're going to run into. Right? And so usually, whenever you get a geometry like this and you plan on making modifications to it, it's always a good idea to try to keep the geometry as clean as possible. Okay. And so a lot of today is going to be, we're going to be making some modifications, and then we're going to go back and fix it. Okay. But the first thing we're going to do is just to make sure that, if there's any kind of issues with the geometry to begin with, let's try to kind of fix those right away. Okay. And so from the SpaceClaim menu, you're going to click on Repair up here. Can't see that at all. Okay. And so this Repair tab is going to allow us to, just like the name suggests, to repair the geometry. And then the first thing we're going to do is we're going to stitch. Okay. And so what the stitch tool is going to do is that basically any areas where there's either cracks or maybe there's maybe geometries kind of overlapping each other. The idea behind the stitch is that it should try to fix those parts of the geometry. Okay. Okay, so let's go ahead and click on stitch. Right. And then for this geometry, actually there's no stitchable edges. And so if you kind of read this kind of tooltip right here, you can see that there are no stitchable edges in the model, right? But if you did have a situation where you did have to stitch the geometry, then this green check mark here would be clickable. Okay. But since this geometry is not too bad, there's nothing too crazy about it. The stitch did not find anything. Okay. But this is kind of a good thing to check usually if you're looking to transform a geometry to shells and beams. I would try a stitch first just to try to kind of fix any kind of glaring issues that may be occurring. Okay. All right. Any questions on this so far? Okay. All right, so the next thing we're going to do is we're going to transform parts of this geometry into shells. Okay. So if you remember what we talked about on Monday, a shell is basically just a 2D representation of a thin geometry. Okay. So in this bridge right here, I see three geometries or three parts that can be transformed into a shell. Okay. I think the most obvious one is the road itself. And so if you look at the road on this bridge, it is very, very thin. Right, so that, of course, is going to have to be turned to a shell. The other part that's going to be turned into a shell is actually the two sides of the bridge, right? And so if you look at the left side and the right side of the bridge here, those are pretty thin. And so if you measure kind of the distance between this point and this point, the thickness of the side of the bridge, that's going to be much less than the length and the height of the bridge. Okay, and so we have three places where we're going to apply shells. Okay. Okay, so to transform a part of the model into shells, we're going to go to this button right here and click prepare. Okay. Let's go ahead and click prepare. And then the other thing you're going to click here is mid-surface. Okay. Remember, we talked about mid-surface on Monday. So a mid-surface operation is basically, you click two parallel surfaces, and then it's going to create a shell in between them. Okay. All right, so let's go ahead and give it a try. So let's click on mid-surface here. Okay. And after you click on mid-surface, you should see there's a tooltip that kind of shows here as well. Okay. And so from the tooltip, you can see that using the mid-surface, we're going to select a pair of offset faces, and all face pairs on the body with the same offset will be detected. Okay, so the way this is going to work is that we're going to click two parallel faces. Okay, so let's start with one side of the bridge. And so let's go ahead and click on this side. Okay. Right, so all I did there was I clicked on one side of the bridge, and then you're going to click on the other parallel side as well. Okay. And so when you click on both sides of the bridge side like this, one side is going to be green and one side is going to be blue. Okay. And so that's a good sign. So that basically says that ANSYS recognizes that these two surfaces are parallel and they're close enough that we can make a mid surface. Okay. And so after you've clicked those two faces and you've turned them green and blue, let's go ahead and click on this green check mark. Okay. And then after you click on that green check mark, so I'm going to leave it here for a second just so that you can see that we've created the shell. Okay, so this gray surface right here, that's a shell representation of what was there before. Okay, and then in the kind of in the faded look or the transparent look, that was the old surface. Okay, and so if you click away, you can see that we've replaced this this side of the bridge with a shell. Okay, so now it's just a very thin, almost paper thin, side of the bridge, as opposed to the other side, which has thickness. Okay.
Sorry, you clicked on both sides?
Yes. Yeah. So I'll show you again on this side as well. So when you click on mid surface here, you're going to click on one side of the bridge to select it, and then you're going to click on the other side, which is parallel, and then it's going to turn like that. Okay. And then after you've selected the two faces, you're going to click on this green check mark, and that's going to execute the mid surface operation. All right, so go ahead and do that. So if you haven't done it already, go ahead and do a mid surface on both sides of the bridge, and then you should also apply a mid surface to the road as well. Okay.
Professor.
Oh, go ahead.
What if we don't? So I click on mid surface and it's not giving me the option to click both of them.
Does it work for the road?
No, I don't even get on the left hand side. You know how you get that drop down? I don't even get that. Mine's a bit different. I wonder it's because I have the student version 2023.
It should still be there. So when you click on prepare, the mid surface, there's no mid surface button here at all.
No, there is, and I click it and I try highlighting the objects.
Yeah.
And it's not it doesn't change color and it doesn't let me select both of them.
I see. Okay, let me check it out. So let me go ahead and finish this up, and then I'll take a look at it.
Actually, Professor, never mind. I figured it out. Thank you.
Oh, okay, cool.
Yeah, thank you.
Mm-hmm. All right, is anyone else having trouble with the mid surface operations?
It only lets me select one side and then it automatically highlights that.
Okay, that's fine. That's it looks like it's automatically detecting kind of a parallel face, which is okay too. Yeah. So if it both are already selected, so if one is green and the other is blue, just go ahead and click on the green check mark and then see if it creates the mid surface. Yeah. Did it work okay? Let me check this. Oh, no, it's looking good. Yeah, so you see how these two are really thin now, and then the road you can kind of almost see through too.
Yeah.
So that means that it's
Okay.
yeah. So then yeah, so I think it might be trying to look for more, but it can't find anything.
Professor, did you click on the road or the bottom beams?
The road, yeah. So the beams will handle in a second. So the beams will turn those into beam elements. But for the road, we only want to transform the road into shells. Yeah.
Okay, thank you.
Yep. All right, everyone else doing okay on Zoom? Oh, I see something in the chat. Let me see.
Yeah, someone asked a question in the chat.
Yep. Unable to create mid-surface faces, could not be offset. That's the first. This cannot be offset. That means usually the offset is computed automatically. Tony, do you want to share your screen real quick and maybe I can take a look?
Yeah, I'll share real quick.
Yep. Okay. Do you mind if I take control for a second?
Yep.
Okay. Is it all yellow? Like, okay. Okay, faces. Huh. It's interesting that your entire model is yellow.
Yeah, it looks super different than what you have.
Yeah. Let me see my screen for a second. Oh, I can't. Okay. Doesn't work on this side either, huh? Let's see, mid surface.
One thing you could do is try exiting it out and try doing everything all over again.
Yeah, that's the last. I'm wondering if something happened with the file because I've never seen it transform all yellow like this. Yeah, once you go ahead and try that. Another thing you can try is let me try the next. Go ahead and try the next step first, and so we can try to do beams first. And if that doesn't work too, I would say go ahead and just reset the program.
Okay, for sure.
Okay.
Thank you.
Yep. Okay. All right. So this is exactly what I was talking about with this activity. Is that lots of things can go wrong in this activity. Okay. Let's go ahead and move on. And so the next step is going to be the beams. Okay. And so we have quite a few beams in this activity. Okay. So remember, the beams are any kind of geometry that is very slender, right? So ones that have one length dimension that's much higher than the others, right? So we have quite a few geometries here that fit that criteria. So we have this beam up top, and we have all these beams on bottom. Okay. Okay. And so to make beams, we're going to use this extract tool. So you're going to come up here to prepare. Okay. And then you're going to click on extract right here, right? And so what that's going to do is that it's going to allow you to click on certain beams in the model. Okay. And you can see that after I click extract, then the certain parts of the beam are highlighting yellow. Okay. And so after we click on extract, all you have to do is just point and click on the beams, and then it's going to transform it into a one-dimensional line. Okay. So it goes a little bit quickly. So, make sure you guys are watching. But basically, all you have to do is just make sure that extract is highlighted here, and then you mouse over on one of the beams, and then you just click. Okay. And so after you click, you can see here that it transformed into a single line. Okay. And we're going to do the exact same thing for all of the beams on the bottom. Okay. And so it's just point and click. Right. So click, 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 and click. Okay. All right, so this extract tool is nice. Remember we talked about on Monday that a beam has to also remember its cross-sectional size and its cross-sectional shape, okay? When you use this extract tool right here, it remembers what that cross-sectional shape was. And so now that's stored within the beam itself, okay? All right, how's everyone doing with this one? Was everyone able to extract the beams out? Okay. All right, everyone on Zoom doing okay? Tony,
Yeah,
was it?
I was able to extract the beams at the bottom of the road, but not the thing at the top.
Okay, oh, that's interesting. Okay, I wonder if something happened. Maybe try making a new project and then re-downloading the geometry. I wonder if something got lost, you know, in the transit of the geometry.
Oh, okay, for sure. I'll try it out right now.
Mhm. Okay, any questions on this extraction part here? Okay. All right, and so, you know, this looks like it's it, right? And so we've transformed the geometry. So everything that was a solid three-dimensional object is now either a 2D or a 1D object, right? And so you might think that, you know, we're done. So we are good to go. Unfortunately, that is not the case, okay? And it's because when you are basically either flattening out a geometry or transforming it into a line, you're losing a lot of geometrical information, okay? So let me kind of show you something just to kind of highlight this, okay? So let's look at the top of this geometry here. So we had one kind of support beam that went all the way across, and it was touching both sides of the bridge, okay? Now let's look at that same part of the geometry here, okay? And you can see, I'm trying to zoom in on it, we have a gap here, right? So now we had two parts that were previously touching are not touching anymore. Okay, and so this is going to cause issues. So later on, if we try to simulate this, basically we would not be able to form a contact between these two parts. And then if we applied a load on this beam, it would just fall down. There's basically nothing holding this beam up. Okay, and so this is the not so fun part of doing shells and beams. That now that we've transformed it into shells and beams, we have to clean up the geometry. Okay. It's like cooking, right? So cooking, I think most people enjoy cooking, but I don't think anyone really enjoys cleaning up after you're cooking, right? So this is the cleanup phase. Okay, so we're gonna do quite a bit here. Question, yes? This one right here? Don't worry about that. That's we'll deal with that later. It's basically we're gonna suppress that part of the geometry once we get to mechanical. Yeah. Okay. All right, so the first thing we're gonna do is we're going to click on, just like before, we're going to click on prepare, okay? And then we're going to click on this tool right here called extend, okay? So let's go ahead and click on extend. Okay. And what extend is going to do is that it's designed for basically exactly this, where, you know, so ANSYS knows that when you create shells and beams in the model, it's going to create gaps, right? And so this extend tool is designed to basically, if you have gaps, then the extend tool will basically fill those gaps. Okay. All right. And so when you're using this extend tool, you have to kind of set the maximum distance here. Okay. And so that maximum distance is basically, it tells ANSYS to look for any gaps that are less than 10 millimeters, and then we'll go ahead and fill those gaps. Okay. Right now, because this bridge is a bit bigger than that, we're not finding any gaps with 10 millimeters. And so what we need to do is we need to basically raise the tolerance on this, or raise the amount of distance that we can get. Okay. So I'm going to use 50 millimeters, and so that is perfectly sufficient for this activity. Okay. So once you change the maximum distance to 50 millimeters, go ahead and hit enter. Okay. And now all of a sudden, ANSYS is showing you that there are some places where it can fix your geometry. Okay. And so it's gonna highlight those with kind of a red dot around that part. Okay. All right, and so to fix the geometry, all you have to do now, so basically everywhere that's highlighted, it's going to extend. And then to extend the geometry, you just have to click on this green check mark. All right, so I'm going to go ahead and click it. And then as soon as you click it, those gaps are going to be fixed. Okay. And you may have to click it more than once. So if you click it once, it might fix it on one side. And you click it one more time, it's going to fix it on the other side. Okay. Yes, question.
We didn't highlight all of the
I know. It doesn't highlight it for me too. So we'll go over why that is in a second. Yeah. Yeah. So just as someone mentioned in the class, it's not all the gaps are going to be filled. It only filled 3 of them actually. So the one up top, and there should be 2 on the bottom that it filled. But there are 5 more beams that are not filled yet. Or excuse me. So it filled 3 on the bottom and 1 up top. So there are 4 more beams that we need to fix, and we'll talk about why that is in a second. Okay. But let me pause here and just kind of check up. So was everyone able to extend at least some of the beams? Okay. All right. So let's go ahead and fix the other beams now. So not all of them were able to connect. And so if you look at 4 of these beams, and in fact, what I'm going to do here is I'm going to suppress the road for a second. And so I think it's this one. Yeah. And so you can hide objects. And so if you want to hide the road here, that it might make things a little bit convenient. And so on the left here, you could uncheck this mid-surface solid 3 and just kind of uncheck this box right here. Okay. All right.
Sorry, what just happened about unchecking?
Yeah. So I just hid the road, and so the road, is this one right here. We'll bring the road back, but for now I'm going to focus on the beam. So I'm just going to just hide it for a second. So to just hide it, you just click on this check mark here next to it. Yeah. Okay. All right. And so without the road here, you can get a kind of a clearer picture of which beams are still not connected. Okay. So we have this one right here, and we have the last 3 up here as well. Okay. All right. So why is that? So to kind of get a better understanding of why it didn't connect, we can view the model from the Z direction. Okay. So to view the model from the Z direction, all I did was on the bottom left here, I clicked on the Z axis, and then it allowed us to look down the Z axis towards this model. Okay. Let me zoom in on this beam right here. Okay. So this beam was one that was not connected. And if you zoom in really close, and so it's a little bit hard to see, but if you look at this dot right here, this dot right here is our beam. Okay. The fact that we can see the dot like this means that it's actually this beam, after we transformed it into a beam, is actually below our model, right? So it's actually not connected to it. And so what happened was that when you try to extend this, ANSYS basically said that, I can extend this beam, but because it's below the bridge, there's nothing for it to connect to. So it would just keep extending out until infinity, which is not what we want. Okay. And so this can happen sometimes. And so, when you turn your geometry into shells and beams, you might get mismatches like this where, even when you try to fix it with an extension, it may not work because the geometry is below what you want. Okay. Okay. And so we need to fix this. The good news is that SpaceClaim has tools available to us for us to fix this these kind of situations. Okay, and so in summary, all we're going to do is we're going to move this beam up a little bit, and so we're going to basically just click and drag this beam upwards until it's intersecting with the bridge. Okay, does that make sense to everyone? So we're basically going to be moving this beam. Let me go ahead and zoom in on the Z-axis again. Try to move to the other side. That's fine. So basically, we're going to be moving this beam upwards in the Y direction until we get an intersection between the two. And then what we'll do is we'll use the extend tool one more time to cover that gap. Okay. All right. Any questions on that? Yeah.
Why did that happen only some of the beams?
Yeah. Because so I feel bad because I always trash this person every single year, but I think, so this CAD model I think was made by a student. And so I think he didn't properly dimension those beams. And so some are up, some are down. And so that's why only some of them are connected. Okay. Yeah. But it works out because this is, like I said, this is a good illustration of things that could happen. Maybe not as uneven as this, if you're getting a professional CAD, probably it's dimensioned well. But because there are so many kind of little issues like this, it kind of illustrates all of those things that could happen. Yeah.
Professor, I have a quick question.
Sure.
So I did the extend tool and everything, and I still have like a red dot on the top part of the truss.
Is it on this little chopstick thing on the top here?
Yeah, yeah, exactly.
Okay,
Is
yeah,
that
just ignore that for now. Yeah, for some programs, for some reason, it tries to extend this. This is also kind of a so I think something in the model that's not supposed to be there, because I think this was made by a student. But we'll deal with it later. So essentially later on in ANSYS mechanical, we're just going to suppress this part.
Okay. And if the on the bottom beams, if they didn't give me an option to click to extend, is that fine?
Yeah, so we're going to fix that right now. So that's what I've been saying,
Okay,
for the
thank
last
you.
few minutes. And so basically the reason they're not able to extend is because the beams are a little bit too far down. So because the beam is now just a one-dimensional object, right? And so in order for it to connect, we actually need to move this up a little bit. I don't know if you can kind of see there's like a little bit of a gap between this little beam right here, this dot, and the bottom of the bridge, which is right here. Yeah,
Thank you.
That's exactly what we're going to be doing. Okay. And so this the moving up is actually going to take a couple of steps. And so, even though this CAD model was made a little bit sloppily, we can still make our adjustments clean. Okay. All right. So the first thing we need to do is that we need to measure how far off we actually are. Okay. And so inside Space Claim, we have this measure tool. Okay. And so this measure tool will, it's useful for a lot of reasons. So sometimes you want to measure certain parts of the geometry that you may have received from someone. Okay. And then we're going to click on this measure tool right here. Okay. Okay. Oh, one more thing. And so before we actually measure stuff, let's go ahead and click on this check mark right here, check box. Because what we want to do is we want to show how much the distance in y, or how far off in the y direction we are from the beam and the bottom of the bridge. Okay. Okay. And so to measure this, it's kind of a two-step process. So you're gonna click on the beam. Okay. One of the ones that didn't connect. Okay. It could be any of them. So we're gonna have to do this 4 times. And so if you're clicking on a different beam than me, the measurements are gonna be slightly different. Okay. And so you're going to click on the beam, and then you're going to hold Control on your keyboard so that we can select the bottom edge of the bridge. Okay, and you have to be a little bit precise with this because we want to match up with the bottom edge, not the whole surface of the bridge, but just the bottom edge right here. Okay, and so when you click on those two, okay, right. So I have both of these selected. You can see that the distance between the two objects in the y direction is 0.4127 millimeters. Okay. Unselect, you just click somewhere, or you can unclick the measure tool right here. And so if you clicked on something on accident, just click on measure tool, unselect it, and click it one more time to select it again. Yeah. All right, and so this is basically telling us that we need to move this beam upwards by a distance of at least 0.4127 millimeters. Okay. All right, was everyone able to get the measure tool and measure that exactly? Okay. You might have different measurements. So all 4 beams that are off, they're off by different amounts, which is beautiful, but it's good practice. This kind of adheres to the old saying to measure twice and cut once. Right? Okay. So now that we know how much we want to move up, okay, the next place we're going to go is this design tab right here. Okay, and so this design tab will let us to actually move or modify parts of the geometry. Okay, so you're going to click on the design tab, and then you're going to click on this tool right here called move. Okay, all right, so let's go and do that. So let's click on move here. Okay, and so when you click move, you're going to click on the entire beam. Right, so this is important. So don't click on just one end of the beam. You want to click on the entire one. Okay. And then after you click on the entire beam, this kind of 3 arrows are going to show up. Okay. We want to move this beam vertically upwards. And so what I'm going to do is I'm going to click on this blue arrow here, and I'm going to move it. I'm just going to drag it upwards a little bit. Okay. And so you can see after I drag it upwards a little bit, it gives you the option there to change how much you're moving it up. Okay. And so what we're going to do is you need to click on that arrow and move it up a little bit just so this box shows up. And then you're going to manually enter how much you want to move it up by. Okay. All right. And so for this beam right here, I know the offset was 0.4127. And so I'm going to offset it upwards by 0.42 millimeters. Okay. You want to move it up a little bit past the measurement just to make sure that they intersect, right? So we're basically trying to get these two objects to intersect each other. So once I've set that, I'm gonna hit enter. Okay. So now this beam should be good to go, right? And so now we're gonna go back to prepare. Okay. So this is after you move the beam. So after you move the beam, go back to prepare. Go ahead and click on the extend tool again. Okay. And what you should see is that after you click extend, now this beam is able to be extended because it actually intersects with the bridge. Okay. All right, so let's go ahead. I'm gonna go ahead and click enter for this. Oh, question?
Yeah, sorry again. How did you get the numbers to
Yes.
show up?
Sure. For the move tool.
Yes. So I click move and everything. I see the arrows. I just need the number to show up.
You're gonna click on the blue arrow, and you're just gonna have to move it up with the mouse just a little bit, just to get the box to show up, and then you can enter the number right now after that. Yeah.
Thank you.
Yep.
I just found out that it's offset like the distance between the wall.
Yeah.
Is 1.4797.
Yeah. And you're going to offset it up by 1.48. So all four beams. So there's four beams right now that aren't connecting. All four have different measurements, and so you probably measured a different beam than I did. Yeah.
Okay, so we need to do that for them.
Exactly. Yeah. Yeah. So for all four beams that aren't connecting, you're going to need to measure, see how much is offset, and then do the move and move it up so that it's connecting, and then do the extend after that. So all four are different. And so it is really annoying, but it's also really good practice. And so, that's what I tell myself every year. Yeah.
Can you use the move up to function?
You can, yes. So you probably have experience with that too. So I've always done just the move here, but which one is the move up to one?
If you click move and then whichever beam.
Yeah.
There's going to be a little pop-up tiny window. Click the Y direction.
Y direction here.
And then there's like a little third icon.
Oh, perfect.
And
Oh,
then
this is
click on
beautiful.
the edge of the that you want to move it to.
Oh, wow. That is beautiful. I did not know that was a thing. Oh, wow. So that actually simplifies a lot of the work that we do. Okay. So thank you for showing that to me. All right. You learn something new every day. All right. And so new method. And so if you've already done the measurements and moved it up, that's perfectly fine. But another way that you can do this is that if you go on to design here, okay. And so in this way, we don't have to measure. We're going to go to design. We're going to go to move. Okay. Okay. And so just like before, the arrow for the move here is going to move up, is going to show up. So you're going to, this time you're just going to left click onto the arrow here. Okay. And then after you left click on that arrow, this new menu is going to show up where it'll let you move the geometry up to a certain point. Okay. And so we're going to click on this up to. Okay. And the nice thing with this is that, and this is my first time doing it. Okay. And so we're going to click on this, this edge right here. Wow, that's so cool. Okay. So after you click on up to, you're going to click on the bottom edge of the bridge, and then it's automatically going to move that upwards. Yeah. Oh, thanks for showing me that. That's super cool. All right, and then after you do that, we're going to click on prepare, extend, and there we go. Wow, beautiful. That's that saves a lot of issues. But this is the hardest part of the activity. Okay. All right, so I'm going to go ahead and repeat that. So I'll show you that move up to again one more time, just so you can see. And so you're going to go on to design. You're going to click on move. You're going to click on the beam. So I have two more beams left. And so click on a beam that is not connected yet. You're going to click on the blue arrow here. You're going to click on up to. Okay, so this basically is telling ANSYS you want to move this beam up to a certain location. And then you're going to click on the bottom edge of the bridge. Okay. And then with one click, it should move it up automatically. And so now that we've done and moved it, we can go ahead and hit extend. And there we go. Wow, I need to modify this activity now. Okay, so one more time. We're going to click on design. We're going to click on move. We're going to click on a beam that's not connected yet. Okay. We're going to click on the blue arrow here for the upwards direction. Okay. We're going to click on this button here for up to. And then we're going to click on the bottom edge of the bridge. Okay. And then one last extend. And there we go. Okay, beautiful. All right.
Switch direction
How do you switch directions?
of the arrow.
Yeah.
Because when I clicked on the beam to the surface, the whole beam disappeared.
Oh, you might want to undo. So you can do Control Z, undo. Yeah, just try undo it and then just try it again. Yeah. Remember, when you click up to, you want to click on just the bottom edge of the bridge, not the whole surface. Mm-hmm. Yep. All right, how's everyone on Zoom doing? Everyone doing okay? Okay. All right. And so now that all of our beams are connecting,
yeah, I have no questions right now.
Oh, question? Yes.
Oh, no, I have no questions right now.
Oh, okay. Okay. All right. And so the last thing that we have to do here is we have to connect the road. So if you can see, the road is kind of floating a little bit as well. Okay. And so just like we did with the beams here, we're going to move that down. We're going to move it down so that's basically right on top of the beams there. Okay. All right. So let's do the same thing. So let's click on design. Let's click on move. Okay. Let's click on the road. Be careful not to click the beams. Okay. Oops, click the beam. Okay. All right. And so just like before, after we click the road, we're going to click on this blue arrow here. We're going to click up to. Okay. And we want this road to be sitting right on top of the beams, just so that the beams could actually support the road. And so what I'm going to do is I'm going to click on just one of the beams. And so they should all be sufficiently close enough. Okay. And so that's going to put the road down there. Okay, perfect. And then the last step, we want to make sure the road actually connects the side of the bridge. And so I'm going to do one more extend tool here. So we're going to go on to prepare and extend. Okay. And you can see now the sides of the road are actually able to extend. So we're going to click on the green check mark here, and that's going to extend the road out just like that. Okay. All right, and so just like that, we are good to go. So we've transformed our geometry here into shells and beams. We've repaired the geometry, so we cleaned it up so that everything that should be connecting is connecting again, right? And so now we're ready to actually move this into ANSYS Mechanical to run the simulation. Okay. All right, any questions on this?
Professor, I have
Yes.
one. Sorry. So
Sure.
when you put move up to, what if the beam is lining like parallel to the wall, and even though I try clicking the corner?
The beam is parallel to the wall. So
Yeah, I'm sorry. It's lining like side by side.
It's lining side by side. Do you want to share your screen real quick just so I can take a look?
Yeah.
Okay. Okay, so yeah, so we want to move the beam up to the bottom surface. Do you mind if I drive a little bit? Okay. All right. So first thing, your interface is quite different actually. All right. So first thing we're going to do. Oh, that's lagging so much. Let me maximize this first and see if that helps. me try this first. So extend. Very interesting. Okay. All right, so let's go back to design. And move. I'm going to turn off the road for a second just to make it a little bit easier to see. Let's turn this off. For some reason, I can't turn this off. I'm trying to click right there. Okay. Okay, it's fine. Whatever. Okay. Oops. Okay. So I think it's lagging a lot, so it's a little bit hard for me to control. But what I would recommend is that to try to turn off the road, at least turn off the visibility for the road first. And then what you can do then is you can select. It's going to be a lot easier to select the beam and then select the bottom edge of the ridge. Yeah. That makes sense. Connection issues. Okay, so I'm going to move on. I'm going to move on for now, just so that just so the others can finish up, and then Ismail, I'll come back to you. Okay.
Could you just show how you did the attaching the road to the beam thing?
Or say again.
Can you just show us how you attach the road to the beam again?
Yes. All right. So we're still using the move up to command. So we're going to go on design right here, and so just like before, you're going to click on move. And you're going to click on the road, and then you're going to click on this blue arrow right here, and then up to, and then you're going to click on one of the road beams right here. And so that's going to put it right on top of the beams. Yeah.
Thank you.
Yep. And then before you close out of this, make sure that you extend. So you go prepare and extend, and just so the road connects with the sides of the bridge. Okay. All right, so I'm going to go ahead and so it's already saved on its own. So I'm going to go ahead and close this for now. Okay. And then so the next thing we're going to do is that now that we're back in Workbench, we're going to double click on model, right? And so this is going to open up ANSYS Mechanical for us, where we can run our simulation. It's going to take a minute to do this. Okay. All right, so now we are in mechanical. And now we are ready to set up the simulation. Okay, so a couple things first. And so, a few people have noticed this already, but in the geometry, there's this kind of weird, chopstick thing being balanced on top of the bridge. Okay. I still don't really know what that is. I think it's just something that's that the creator kind of put in there, maybe to troll people. I don't know. Okay, but we don't need it for the simulation. So if you look at the geometry here, there is one surface here or one part that has a question mark. Okay, and so that is exactly the little kind of little twig thing that's on top. Okay. So I'm going to right click on this, and then we're just going to suppress it. Okay, and because oops. Suppress. Okay, and so after you suppress it, you can see that the little twig thing kind of disappears. Okay, I think it was, it looks like it's already a beam type geometry, but it just didn't have any thickness. Okay. All right, so now that our parts are good, okay, the next thing we're going to need to do is connections. Okay, so right now we've created all these parts. Okay, so each beam and each shell is kind of its own individual part. Right. Before we can actually run a simulation on this, we need to make sure the parts are connecting in the way that it should. Okay, because right now all the parts, they're just, even though they're touching each other, they're not actually, there's no bond between them. Okay. All right. And so the way we're going to do this is we're going to insert a, you're going to right click on connections in the project outline. You're going to go to insert, and then you're going to click on manual contact region. Okay. And so this is going to allow us to basically connect different parts of the geometry. Okay. Okay. All right. And so the next step here is to basically select all the parts that need to be connected. Right? So there's actually 5 regions that we need to connect to. So we need to connect the side of the road to the bridge. Okay. We need to connect the ends of the beams to one side of the bridge. And then we need to connect the other sides of the beams to the other side of the bridge. Okay. Same thing with the road. So the road on this side needs to be connected to the bridge. And then finally, the road needs to be connected to all of the beams. Okay. Okay. And so you can do this in whichever order that you want, but the first thing I'm going to do is I'm going to connect the beams to the bridge. Okay. So what I'm going to do, and it might help to do this too, is to switch to vertex selection mode. Okay. Just so that we can click on the ends of the beams. Okay. So I'm going to click on this vertex selector. And I'm going to zoom in here just so I can click on this. Okay. And so you should see a little green dot highlight right at the end of the beam. Okay. You're going to hold Control on your keyboard. Okay. And you're going to click all of the ends of the beams just like this. Okay. So there should be 8 of them. So you should have 8 green dots. And then with all green dots highlighted, you're going to come here to the contact and you're going to hit apply. Okay. And so that's telling ANSYS that we're going to establish a contact between these eight vertices, these 8 points, and one other part of the model. All right. And so the other part of the model that we're going to connect it to is the side of the bridge. Okay. And to do that, we're going to click on face selector mode and click on the side of the bridge here. And then we're going to make that our target. Okay. Okay. So after you've done that, we've gone ahead and made this connection. And so you can see from the figure on the right here that we've made connection between all these vertices and the bridge. Okay. And since this is a bonded support here, that means these parts of the model are going to be bonded together. And so when we run the simulation, all those parts are going to connect to each other and stick together. Okay. All right. Any questions on that step there? All right, so I'm going to go ahead and repeat this. And so we need to make connections with all the other parts of the geometry. So I'm going to go ahead and right click on contacts here and insert another manual contact region. Right. And so I'm going to do the same thing on the other side of the bridge. Right. So I'm going to click on vertex selector. I'm going to click on all of these points here. Okay. With Control held down on my keyboard. Just make sure we have all 8. 1, 2, 3, 4, 5, 6, 7, 8. Good. Okay. We're going to apply those as the contact. And then the target is going to be the other side of the bridge. Okay. And so that creates our other contact region there. Okay. We're going to insert another manual contact region. So next I'm going to connect the edge of the road to the bridge. Okay. And so this one you might have to hide the geometry here, although you might be able to get it without it. Okay. All right, so I'm going to click on edge selector. So let's go ahead and click on the edge of the road. Okay, just one side, just one edge like that. Okay. and I missed it. All right, you want to be careful here. So when you click on the edge of the road, you want to make sure you click on the road and not the bottom edge of the bridge. Okay. So you might have to zoom around here just to see. There we go. Okay. If you look at one side of the bridge, the road kind of sticks out a little bit, and so you'll be able to grab that edge a little bit easier on that side. Okay. And then the target, just like before, we're going to click on the side of the bridge. All right, I'm going to do it on this side as well. So I'm going to create another annual contact region. Okay. We're going to click on the edge of the road. And then we're going to click on the side of the bridge, just like that. Okay. And then the last thing we're going to do is we're going to make sure the road is connected to all the beams. So we're going to right click on contact, insert a manual contact region. Okay. And this time we're going to select all the beams on the bottom. Okay. So just like before, hold control on your keyboard. Bless you. Okay. And so you should have 7 edges here. Okay. And then for the target, we're going to click on the road itself. Okay, so now the road is bonded to all of the beams. Okay, so in total, you should have 5 different contact regions, which kind of highlights kind of what we did there. Okay, so I know I went kind of fast on that one. So is anyone having issues with making those contact regions? I'll give you guys about 5 minutes to to make those. Okay.
Did you do anything to the item with the question mark?
Yeah, we suppressed it. Yeah, so the question mark item in the geometry, just suppress it. Yeah. Okay, how's everyone doing with the connections? Everyone doing okay on this? Zoom people, you guys doing okay?
Yes. I could only speak for myself now, so.
Okay, no, that's fine. It's good. Good, you're doing well. Anybody else? Anybody else having issues?
No, no problem.
Okay, good. Okay, and so with that, it's that's all the new stuff for this activity, right? So we spent a fair bit of time correcting the geometry and making the connections, but now it's just kind of good old meshing and boundary conditions. Okay. So just so I can show you the results here, I know in the activity I asked you to do a bit more modification for the mesh, but let me just generate a default mesh. Okay. Okay. And so if you generate a mesh, you might look something like this. So I actually don't like this because this actually makes it look like these are solid elements. And so what I'm going to do. Right, and so if you don't like this style, and personally I don't like the style because it makes it look really bad. What you can do is you can turn off this thick shells and deep style. So after you create your mesh, go to display at the top here, and then you're going to uncheck this setting here for thick shells and beams. Okay. Right here. So this is just a preference thing. It's just a visual thing. But I personally don't like the thick shells and beams. I like it to actually look like we turn this into shells and beams. Okay, so that's a mesh. I know in the activity I asked you to do more with that, but just for the sake of showing you the finished product, I'm just going to go with the default mesh. Okay. All right, let's go ahead and add our boundary conditions. So I'm going to add a fixed support onto one side. We add the fixed support onto here. All right, and so the boundary conditions as well. This is something I'm asking you to kind of do on your own. But for now, because I want you guys to basically come up with your own loading scenarios. But just for now, I'm going to show you kind of a very basic simulation. Okay, so I'm going to fix the road on both sides. And then what I'm going to do is I'm going to put a force on top. So let's put a force of, let's say, 250 pounds, okay, going in the Y direction. So let's do components minus 250. Okay, so we're going to apply a force that's pushing downwards. And then we're going to see the total deformation as well as the equivalent stress. Okay. All right, so let's go ahead and solve this. Okay. Right, and so from here you can start to see the results. Okay, and so we can see the total deformation here, and so you can see here what you should see is that the deformation should kind of be in spots like this, right? And so what's happening is that basically the beams are providing structural support to the road as it should, okay? And it's deforming in the places in between the middle of the beams, okay? And then we can look at the equivalent stress field as well. So you can see which parts of the model are undergoing a lot of stress, okay? Okay, so I know there's still some people having some issues, but I at least wanted to show you some simulation results just so that you can kind of compare, okay? Let me go over kind of the rest of the activity just so that you guys are all aware of kind of what I'm expecting you to do. Okay. All right, so what we did basically together was we did all of problem 1 together. Okay. And just very quickly, I showed you problem 2 and problem 3. Okay. Okay, problem 4 is to basically just show me some of your results. So under your default loading scenario, show me the total deformation, show me the equivalent stress and the equivalent strain. Okay. You're going to answer a couple questions on this. Okay. So that's problem 4. So that's pretty standard. So, we have something like this in all the activities so far. Okay. All right. And I show you some screenshots of my results just so that you compare them as well. Okay. Problem 5 here is going to be the mesh convergence test. Remember, we discussed this a little bit on Monday, right? And so the idea is that, because we're using shell and beam elements, the mesh should converge pretty well. Okay, and so if you make a plot of the maximum deformation versus the number of elements, okay, and so basically you're going to rerun the simulation at several different element counts. Okay, so you're going to change the mesh size for each one, and then you're going to plot those results into a line graph or a scatter plot. Okay, and what you should see is that at a certain point, the values of the deformation should plateau. Okay, and so you should see this kind of flattened part of the graph. Right? And so this is good. So this is basically telling us that we've reached convergence on this mesh right around this area right here. So I'd say this is probably the convergence point. Okay. All right. So I want you guys to do that, and I want you to run at least 10 simulations for different mesh sizes. Okay. I know on the homework here I said to do the equivalent stress, but you can do the equivalent stress or you can do the deformation as well. Okay. You're going to get a much cleaner graph for the deformation, so it's going to look like this. But if you want to try with the equivalent stress, that's fine as well. Okay. Okay, problem 6, I want you to change the boundary conditions a little bit. And so instead of just fixing it at the ends of the road, I want you to try fixing it at the ends of these beams. So basically to imagine that there's pillars on each of these points. Okay. Right. And then for problem 7, I want you to retry the analysis with solid elements. And so, with no shells and beams. And so just basically as it is. Okay. You may not be able to do problem 7. And so what you'll see very quickly is that the cost gets pretty large for a geometry like this. And you might run into some issues with the element count. Okay. And so if you're not able to run the simulation, that's fine. Just say that you ran into some errors. I expect the majority of people will run into errors with this, and it has nothing to do with with your skill as an FEA engineer. It's just sometimes the software just doesn't like to run solid elements on this. Okay, so give it a try. If it works, great. But if it doesn't, then don't worry about it. Okay? And then the last part here is just summarize your results. So just like before, just write a brief summary of kind of your principal conclusions from this activity. Okay. Okay. All right. Any questions on the rest of the activity? Okay. All right. So we still have about 7 minutes left in class, and so I'm gonna go around and kind of help people who are still kind of a little bit behind. But if not, that's it for class today. And so if you want to head out, you are definitely welcome to do so. So thank you guys for coming in today. I know this activity is quite long, so that's why I'm giving you a couple weeks to do it. And if you run into any issues, just always let me know. Okay, so hope you guys have a good weekend, and I will see you guys next week. All right, Ismail, are you?
Thank you, Dr. Chan.
Oh, thanks, Ivan. Yep. Do you want to share your screen again so I can maybe take a look, maybe see?
Yeah, of course.
Maybe it works a bit better now.
Thank you. Yeah, I'm hoping.
Okay. All right. It looks like. Oh, this is what you mean. So you have one beam, this kind of a grayish black beam that's kind of going parallel to the road, right?
Yeah, so it's because what I do, I think I made it like the other beams. I clicked that
Oh, when you clicked extract, you accidentally clicked the road as well, right?
yeah, there you go. So I couldn't
I
find
see.
the word.
Oh, okay.
Do you think if I click it again, it'll come back?
We may have to undo it. So let's try clicking. So you see on the left-hand side menu, there's something called beams.
Yeah.
Okay, so let's click on that. Oh, it's the first one, right? So extracted beam 1.
Yeah. Did I delete it?
Yeah, I know it highlighted for a second. So let's go down again. So let's do beam 2. Click on that one.
I can make this disappear and maybe. Okay.
Let's try extracted. Oh, is it the third one?
It's this one. Yeah.
Okay.
Yeah.
Okay. Let's try right clicking on that one, and let's see if we can undo this.
Would it just be delete?
Let's try delete. Yeah.
Oh, oops.
All right. Control Z. Come back.
Maybe I done goofed up, Professor.
That's okay. It's okay. Let's try again. So let's try expand. Let's see what that is. Okay. Okay. So it just shows the geometry below that.
Yeah,
Okay.
I think
so it's right.
I think I control Z it to that hopefully back to normal.
So I mean, in the worst case, you can just kind of start the project over again, and then and start from the base geometry. That's always an option. But let's see if we can undo it, because I've actually never tried this myself too. Let's try right clicking on extracted beam one more time. Let's try exclude from simulation.
No,
What did that do? Can you zoom out again? Let me see.
yeah, sorry, my thing's down. It went inverted for a second.
Let me search
Okay.
it up on
So this the middle thing isn't the problem. Honestly, I don't mind restarting over. It's when I click this beam and I try to make the beam move to the edge, it lines up. I think I can just show you. I think I'll do
okay.
it.
Yeah, why don't you show me?
Yeah, so move to, okay. So let me click this up to, and then let me click this edge. Then it, what the heck? I accidentally clicked the middle line.
Oh, okay. Oh, but I see. So okay, I see. Okay.
Yeah, yeah. So but that will happen anyways to them.
Yeah. Click on go ahead before you click on up to, let's click on the blue arrow. Do you see on the beam itself?
Yeah.
Okay, so let's tell, and I think if you click on that blue arrow, it should tell which direction I want to go. All right, so
Okay.
let's click on up to again. And now let's try clicking on the bottom one. Oh,
That's upsetting. Well,
Oh.
that's still in the right direction because last time it was lining up.
okay, I think it moved. I saw it move a little bit. Let's try doing extend one more time. So go back to prepare and extend. It's
Okay.
very subtle. It's not going to look like it moves all that much.
Prepare and extend.
And there you go. Yeah, so that one is there. So go ahead and click on the green check mark.
So if I click on the green check mark, would it automatically do it to everyone?
Everyone that well, it'll extend all the ones that it can, and so it's looking for places where it can extend. So do you see all those little red circles?
Yeah, and this one, it was the same beam that we worked on. Will I have to do the same thing?
Yes, you're gonna have to do the same thing for all the other ones as well. Yeah.
I see. Okay, so I should probably make a note of that to click the blue arrow before I want to move to.
Yes, because I think it needs to know which direction that you want to move to.
Okay, yeah, makes sense, Professor.
Yep.
Thank you. Yeah, that's the only problem I have. I'll watch the video and try to keep up.
Okay.
You know.
Okay.
was
Yeah,
stuck
and then
on this.
just let me know if you have any other issues too.
All right, sweet. Thank you.
Yep. All right. Anybody else having issues with this activity? Yep. Okay. Oh yeah, I tried to keep up. Yeah, I didn't apply any sentences, so I just did a dummy mesh. So it was a pretty bad mesh. So you're gonna want to do those things. So there's more instructions. Oh, okay. But basically, you at least want to change the size. The size of the you want to make sure that all the elements are okay. And one thing, I mean, this is a preference. You can feel like this is, but I don't. It's out here. Better display. It shows. So it actually looks like. So I personally like show is it the other way? You might think it's actually self. But it's a preference. So you can use it. Okay. So what did you do? So I kind of missed it.
when I did my connection, I accidentally did the left side.
Oh, okay, okay. Yeah, so all I did, so I just applied very basic boundary. So what I did is I applied after this looks fine.
Okay.
I applied a fixed support on these two ends of the road.
On just the edges.
Just the ends, yeah.
Oh,
Yep. And then I just applied a simple Y direction force.
Oh.
Simulate their cars. I think in the activity it's a pressure. But I use it. We want to see the surface.
Professor?
I think
okay, is that all you did?
Yep, that's all I did.
Oh,
Yep, thank you. Hey Chris, what's up?
Hey, so I went into space claim, clicked stitch. No problems. I clicked gap and it says there's a problem.
Oh yes, I thought that was part of it. There is one gap that has to do with the little, like twig thing up top. There's like a little twig that looks like it's on top of the bridge. I don't know why that's there, but you can just ignore that. So there's going to be a gap there. That's okay.
Okay, so it looks like a little red thing.
Yeah. Just
Okay.
ignore it. It's okay.
Okay. So I don't need to deal with it at all.
Yeah.
Okay.
Professor?
Yep.
For some reason, I'm just getting an error when I'm trying to solve it.
Did you apply the boundary conditions, the loads and the fixed support?
Yeah. So I've like you said, I fixed both the edges, and then the force it's acting on my Y direction, so it's
Okay.
downwards.
Okay.
And when I click on solve, it just comes as.
Do you see on the bottom it says 2 messages?
Just a second. I'm not able to.
It's on the very bottom. So there's like a blue strip on the bottom. It says 2 messages there.
Oh, just a second. The screen share thing is just blocking it, so I'm just trying to move that.
Okay. Yeah.
Oh, got it. Yeah.
Okay. So let's see. Move these up and let me see. Pivot warning. Let me see all your connections. Make sure they're all okay. Okay. So when you connect the beams to the bridge, you're not connecting the beams itself. You're connecting just the ends of the beams, and so it should be a vertex, not an edge. You know what I mean?
Okay.
Yeah.
So it should be I should do this.
No, so there's the one next to it, which is vertex.
Oh, the vertex. Okay, so
Yes.
it's not the edges.
Exactly. Yeah. Yeah. Change those and then give it a try. I think it's the model is moving too much because it's not properly bonded.
Oh, okay.
Yeah. Just give me the clean. I'm not sure. I usually just use just like
I'm getting a pressure.
Okay, yes. So I didn't mention this before too, but the order in which you do the contact and the target actually matters. So usually for the target, you want that to be the bigger of the surfaces.
Okay.
And so one way that you can swap it really easily. So right click on this.
This one?
Yes. And then split contact target. Great.
Thank you.
Yes.
Do we need to do one for the beam on the top?
Yes, you do. So the beam on the top should be connected to this bridge and that side.
That's because it's gonna be like this. So
Yes.
it's not included.
So you can make the top one. So let me see your other bars. So you can actually make it part of this one. So you can also, in addition to the 7 vertices here, you can also select this 8th one up here too, because that's also going to be connected to this side of the bridge.
Oh, so it doesn't have to be at the bottom edge.
No, so as long as all these have the same target, so the same target is going to be that side.
Okay, I thought it's only that bottom.
Oh, no, yeah,
Okay.
you can select it, but you can make it separate as well too, so it's all the same.
Okay.
Yeah.
Cool. Thank you.
Yeah. It's good. Looks
Yeah,
like you're getting a result, so that looks good.
Yeah, got it. Thank you, Professor.
Yep, no problem.
Professor, also the next assignment, is it going to happen during a spring break or after the spring break?
I think we'll do it. I'll need to see because the schedule for this class is a little bit different because last time I taught this was in the fall. And so I was able to get that next activity in before Thanksgiving. I don't want to do an activity right before the spring break because I know you guys will be working on the project. And so we might do the next activity after spring break.
So you will give it to us once you come back after spring break.
Exactly. Yeah.
Okay,
Yeah.
cool.
Because this one we need to get in before because otherwise we're going to fall behind. But I think the next one we can probably do after spring break, just so that you can just focus on the project after this activity.
Okay, cool. Thank you.
Yep. Chris, any final questions before I close the call?
No, I'm good. I'm just
Okay.
doing assignment and all that.
All right. Sounds good. All right. I'll see you next week. Have a good weekend.
night.
Good night.